Alrighty, welcome back, boys, girls. It's your main math man, Mr. Shank, coming to you live from Walker Grant Middle School. And I know a lot of people are going to be freaking out. Why do you skip so many things? Well, it's fine. We need to be able to kind of work with the same consistent things, and we want to make sure that we are spending time working with that 8.11 through 8.18 as our main study topic. So for 8.11, this is going to be the SOL where you compare and contrast probabilities of independent and dependent events, and you want to be able to determine that probability as well. So you want to be able to kind of figure out, okay, is this independent, is this dependent, and then what is that correct value? Make sure the main idea for probability is this: all probabilities are between 0% and 100%. If you are getting values that are below or above this, meaning below 1 and below 0, make sure that you are correcting your answer. Some other key ideas are this: for independent, you are saying that the some key words for independent, you have replace, put back, you have, working with a die or a number cube. You can also have a spinner. Anything that mainly does not change. Where separately for dependent, that means that you are depending on an outcome. So it does not replace. You could say it does not replace, does not put back. It's the candy is eaten. What's another example? You are mainly changing the denominator. Meaning this: when you are talking about a sample space, you're talking about how many cards are in a deck, how many marbles are in a bag. If you are taking one out and not replacing it, you are changing that denominator. That's that bottom of the fraction. And that will changes the outcome, and it mainly changes the probability. And so for an example, let's say this. Let's do number. This is let me scroll this up. For number 3 on page, page 23. Page 23 in your study guide. It says a spinner has 5 equal sections labeled A, B, C, D, and E. So make sure you can draw it out for yourself. It doesn't have to be perfect, but you guys get the idea. 1, 2, 3, 4, and let's say 5. Sure. A, B, C, D, and E. And then it has a coin as well, where the coin is heads and tails. Heads and tails. So you want to make sure that you have this. If they spun the spinner and flip the coin each one time, what is the probability the arrow will land on the section labeled A and the coin will land on heads? So you're looking for this. Do these affect each other at all? Meaning, do they change or do they not change? Well, are you shading one of these off? Are you cutting it out? No. And so we know this is independent. And so since independent, you can calculate it like this. You would say the probability of what event are we looking for? Well, we are looking for how many A's are there on this spinner. Well, there's only 1, and so you'd say there's 1 out of how many total we have. Well, there is 5 total spaces, so that's our denominator. Again, you can use that Desmos calculator for yourself to figure out, okay, hey, how do I change from this, let me see if I can zoom in here a little bit, how do I change from this fraction of 1/5 to a decimal? Or if you have that decimal, let's say 0.2, how do I change that to a fraction? Well, you hit that nice little button right there, and it changes it to a fraction. So make sure that you're not only saying, okay, I can change back and forth between those, but you have to make sure if the answer choices are in a fraction, decimal, percent form, that you are careful on which one you select. So we're saying this could be 0.2. Then we have the probability of flipping a tails, or excuse me, let's say flipping a heads. It doesn't matter because they are both the same. It is 1/2, which is 0.5. Anytime you are working with probabilities, make sure that you are, let's back up a little bit, make sure that you are multiplying them together. Meaning this, the probability of spinning an A and, lots of breaking pencils this time, spinning an A and flipping a heads, again, and means multiply those two fractions together, or those two decimals, whatever works. We would have 1/5 times 1/2. Again, if I'm working with multiplying fractions, you want to multiply those numerators together. So 1 times 1 is 1, and multiply the denominators together. 5 times 2 is 10. So our value could be 1/10, which is equal to 0.1 or 10%.